In the last 60 days, 30 security vulnerabilities were filed against a single protocol. 38% of its servers have zero authentication, and it's connecting AI agents to your Gmail, your databases, and your cloud infrastructure right now. Welcome to AI's newest attack surface, Model Context Protocol. Today kicks off a three-part series on Model Context Protocol security, one of the most critical emerging threats in the AI landscape. This is Episode 1. What is MCP, and why do attackers love it? Let's start with the fundamental challenge that MCP was designed to solve. Large language models are incredibly powerful, but they have a critical limitation. They're isolated from the real world. An AI trained on data from 2024 can't tell you today's weather, check your calendar, or access your company's internal documentation. It's trapped behind information silos. Before MCP, every application needed custom integrations for every service. Want your AI to access Gmail and Slack and Google Drive? That's 3 separate integrations, 3 different authentication flows, 3 different maintenance nightmares. Model Context Protocol changed that. Think of it as USB-C for AI, one standardized interface for connecting AI models to any external tool or data source. MCP has a deceptively simple architecture with 3 core components. Let's break them down. First, the MCP client. This is your AI application, Claude, ChatGPT, or any LLM-powered assistant. The client talks to the AI model and coordinates everything. Second, the MCP server. This is lightweight middleware that exposes specific capabilities through the protocol. One server might connect to Gmail, another to your database, another to your file system. Third, the actual resources and tools. Your Gmail inbox, your Google Drive, your Postgres database, your internal APIs. Here's how they work together. You ask your AI assistant, summarize emails from my manager this week. The MCP client passes this request to the Gmail MCP server. The server authenticates, queries Gmail's API, retrieves the emails, and passes the data back to the client. The AI model processes it and gives you the summary. The power is in the standardization. Build an MCP server once, and any AI application can use it. No custom integrations. No vendor lock-in. So why do attackers love Model Context Protocol? Let me count the ways. Reason 1. Centralized access. MCP servers typically store authentication tokens for multiple services. Compromise one server, and you gain access to Gmail, Google Drive, Calendar, Slack, everything connected to that server. Security researchers call this the keys to the kingdom problem. Recent analysis of over 500 MCP servers found that 38% completely lacked authentication. 0. That's not a misconfiguration. That's servers deployed in production with no access controls whatsoever. Reason 2. Invisible exploitation. When an attacker uses a stolen OAuth token through MCP, it looks like legitimate API access. Your standard security alerts won't trigger. There's no suspicious login from an unusual location. It's just the MCP server doing what it normally does. The attack blends perfectly into normal traffic patterns. Reason 3. Supply chain vulnerabilities. MCP servers are executable code. Security researchers analyzed over 30,000 MCP skills, small extensions that add capabilities, and found that over 25% contained at least one security vulnerability. Developers download these from public repositories. If an attacker compromises a popular MCP server or poisons its dependencies, they've got a pipeline straight into enterprise environments. Reason 4. The confused deputy problem. MCP servers execute actions on behalf of users, but if they're not implemented correctly, privilege boundaries blur. A low-privilege user could potentially access resources available to the server itself, violating the principle of least privilege. Let's map MCP security to our core frameworks. From a NIST AI risk management framework perspective, MCP introduces risks across multiple functions. In the govern function, we need policies for MCP server vetting and approval. In the map function, we must document which AI agents have access to which resources through MCP. In the measure function, we need continuous monitoring of MCP interactions. MITRE Atlas helps us understand adversary tactics. MCP creates opportunities for reconnaissance through enumeration of connected services, resource development through poison skill repositories, initial access through vulnerable servers, and persistence through stolen OAuth tokens. And OWASP LLM Top 10 ranks prompt injection as the #1 risk. In MCP ecosystems, prompt injection isn't just about manipulating text responses, it's about triggering automated actions across enterprise tools. The stakes just got higher. Now that we understand what MCP is and why it's a target-rich environment for attackers, we need to dig deeper. In Episode 2, we'll explore the technical attack vectors in detail: prompt injection through MCP sampling, tool poisoning, context manipulation, cross-server hijacking. We'll map each technique to MITRE Atlas tactics and show you exactly how these exploits work. And in Episode 3, we'll focus on defense, zero-trust architectures for AI agents, scoped API keys and short-lived tokens, policy enforcement points, immutable audit trails. We'll give you a practical security framework aligned to NIST AI RMF that you can implement in your organization. Model Context Protocol is here to stay. The question isn't whether to use it, it's how to use it securely. Understanding the threat is the first step. I'm Bobby, and this is Security of AI. Thanks for watching. Please like, subscribe, and comment below.